Hello everyone, welcome to 1045 Engineering. Today we are here with yet another video in Blind 75, a better Blind 75 coding series. So let's quickly jump to our problem statement. So today we are going to invert binary tree. We are given a root of a binary tree. We have to invert the tree and return its root. So just to understand, the binary tree right now is like 2 and it has two children, 1 and 3. We are going to revert the binary tree, so it will look like head would remain the same, the children gets reversed, so 3 first, 1 later. Let's go to the problem statement and start solving. We are going to achieve it in O of n time complexity. So last time we had already solved up till valid palindrome question in our grind 75 coding series. Let's jump to the next one, which is invert binary tree. Okay, let's quickly take a look at the question again. Given the root of a binary tree, so we are given a root here. You can understand the tree node from here that has value left, right, tree node, constructors. Okay, we are given the root of a binary tree. We have to invert the tree and return its root. From the simpler example, we are going to invert the children's 1 3 2 3 1. Similarly, on a bigger binary tree, what would happen is all of it is going to get inverted. So if you see, 4 has two children, 2 and 7. In the inverted one, 4 has 7 first, 2 later. Now if you look at 7 had children 6 and 9, but now this new 7 has children 9 first and 6 later. So we are actually inverting all the children from the root node all the way till the leaf nodes. Okay, so the simplest way to solve this approach. Okay, just take a moment, pause the video and think for the approach that you are going to take. If you have already decided with the approach, please let me know in the comment section and let's move forward. Okay, the easiest way that we can achieve this is we solve it recursively. So we start with 4, we go to 2, we then go to 1, we then check it does not have any leaf node. We come back to 2. Now 2 has two child nodes 1 and 3. We revert its children, so 3 first, 1 later. If you see in this 2, 3 came first, 1 came later. Similarly, on the other hand, 7, from 4 we came to 7, from 7 we came to 6, 6 does not have any children. We went back to 7, we came to 9, 9 does not have any children. So now at 7 we reverse the children of 7 from 6 9 to 9 6. Okay, and now we go back to 4 and we reverse the children from 2 7 to 7 2. Okay, let's look at the solution and see if everyone is on the same page in this one. Okay, yeah, let's we are going to keep a base condition, because always remember the base conditions. Yeah, base condition. What is going to be our base condition? If the root is null, return null. So when we arrive at 1, since we are going to solve it recursively, when we arrive at 1, it has no children. So when we recursively call its children, they would be null. So we'll return null from them and we are not going to make any reversal there. Okay, so for null check, we'll put a base check if root equal to null, return null. Simple. Our base check is complete. Now we are going to go recursively. Okay, so let's first see this. Invert the left subtree. Okay, so for 4, 2 and 3 is left subtree, 7 6 9 is right subtree. It can have more children if needed, or if it doesn't, it's not the case. Okay, so 4 has left subtree as 2 and 3 and 7 6 9 as right subtree. So we are going to invert the left subtree by calling the function recursively. Okay, so right now the call is being made to root, which is 4. Now what we'll do is we'll call the left subtree and we'll pass 2 as the root. Okay, how can we do that? We'll simply say tree node, using the tree node class, tree node left is equal to invert tree, calling the same function again, so it's recursive call, and we are passing root dot left. Simple. So we are calling the invert tree function again, and we are passing the left node. So we say root dot left. We have passed 2, and when the inversion of this left subtree is complete, it is going to revert us the node or the root, which will be 2 here for this case, right? And that will become our left node. Similarly, we are going to do the same for invert the right subtree by calling the function recursively. This is a very simple problem statement if you understand it, and once you have understood it, it's really simple to remember. Okay, so what we did for left subtree, we are going to do the same for right subtree. So let's start. Tree node right is equal to, we are calling the same invert tree function again, invert tree, and we'll pass root dot right. So on this side 769, we are calling the invert tree function again on the right child, and we are going to say please invert this subtree and return me the root of this subtree. So 7 will be returned. So our left one will get 2, right one will get 7, and then we'll simply swap them, right? So we'll say swap left and right subtrees, right? So we are going to say root, which is this one, so 4 in this case, root dot left is equal to right, this one, whatever we are getting as the root for the right subtree. Similarly, root dot right is equal to left. So if you see, 4's left became 7, which was earlier right, right became 2, which was earlier left, and then in the end we are going to say return the root node. So we'll say return root node of the inverted tree. Okay, very few lines of code. If you see 1, 2, 3, 4, 5 lines of code and a base condition. Okay, but let's understand this with the example. Let's take a dry run. So we call from the root, which is 5 right now, which is 4 right now. We'll say 4. Root is at 4 here. We checked left is equal to invert tree and called root dot left. So invert tree function is called, so this function is called here. Root dot left was passed, so next came root dot left, which is 2. So we got 2 here. We came inside the function, we checked if root equal to null, no. Again we call, again we are going to recursively invert the subtrees. So for 2, left subtree is 1 and right subtree is 3. We are going to call invert tree on root dot left, which is 1. Again this invert tree function is called, so right now our root is at 1. Is the root equal to null? No. We are going to again call tree node left, invert tree, root dot left. Now when we say root dot left, that is null, right? Because 1 does not have any children on the left side. It does not have any child on the right side either. So this is null. It returns null from 1. Then we call root dot right. So 1 is our current root, root dot right is also null. This function stays the same. So for left and right, actually it was null, it didn't go in. So when we are at root 1 here, we said left equal to invert tree root dot left. It came inside, it was null, it was done. Right, it came inside, it was null, it was done. we tried the swap, they are null, it didn't change anything for 1 and returned the 1. So 1 came out of this loop, and here we got a first left subtree child as 1. Then this method was executed for row 2. So 1 function is complete, we are at 2, we completed its left child. Now we are going to do the same for right child. So it's going to call 3, then check the children which are null, and then return back 3 again. So we'll get 3 here. Now we are going to say root, which is 2 is a root. Root dot left is equal to right. So 2's left will become right 3, and root dot right is equal to left. So earlier, if you see, left was 1, right? Now left will get the value of right. So left will become 3 and right will become 1. And we are going to return the root, which is 2. So after once with 2, this inner operation is complete, 2 is going to look like this. 2 with 3 on the left and 1 on the right. Now similarly, 2's function will get over. It will go back to the root 4, and now this complete invert left side is over. Now the similar operation is going to take place for invert 3 root dot right with 7. It is going to reverse the children from 6 9 to 9 6. Once that is complete, our final children left and right for root 4 are going to be, on left side we have 2, so 2, on right side we have 7, so 7. And internally they have now reversed their child nodes, right? So for 2 1 3 became 3 1, for 7 6 9 became 7 9 6, but 2 and 7 are still the same. So now left is 2, right is 7. Now we are going to swap it for the root dot left. Root is 4, so root dot left is equal to right. So earlier left was equal to 2, now root dot left became right, which is 7, and root dot right became left, which is 3. So which is 2. So now 2 and 7 swapped again, became 7 and 2, and we return the root, which is 4. Okay, make sense? Good. So let's run it. Okay, it does feel good when it compiles in one time. Well, it was a small problem statement though. Okay, let's submit and check. Great, beats 100% of the users, because yes, we are doing it in O of n, plus we are doing it recursively, and this is the smallest and fastest solution possible. Of course there can be better solutions, but this is the fastest one as per my current knowledge. Great. Okay, so one more thing. So we have solved the invert T binary tree problem as well. We'll mark it done. Let's get back here. So we resolved the solution in time complexity of O of n. That's all from today's video. If you guys have any other approach on the same solution, please let me know in the comment section, or if any part of the solution was not clear, please let me know in the comment section. I'll be happy to engage. Thank you everyone. That's all for today, and please like, share and subscribe.